So the initials of this video might seem a little bit abstract, and I understand. Reason to that is because when you're trying to build a house and you're laying the foundations of the house, right? So the foundation is very, very abstract, right? It's just like doing the foundations, like seeing the effect of what you are doing, right? But when are you going to see the effect? You're going to see the effect on the long of the foundation on the long run, right? So I needed to put it out there, so just in case when you're watching the video, it seemed a little bit abstract or abstracted, and like, what are we trying to do here? What are we trying to achieve here? I just want to give you an assurance that just hang on, just stick around the video, just keep following the video, and digest the video. You will totally understand a lot when I tell you a lot about relational mappers. Trust me when I tell you that. So, a little side note, this video was not meant to be a standalone course. It was meant to be a part of a series that I was recording, which is titled Object Relational Mapper, working with SQLAlchemy in Python. But when I was teaching the video, I discovered that SQLAlchemy has a lot going on over there, and I needed to cover every single concept, and I needed to make sure that every single audience is actually included in the series. So when I was teaching, I needed to touch some areas, and I said, okay, you know what I can do? Since there's a lot going on over here, then I now said, well, do you know what I can actually do? Let me like teach you guys how we actually worked on our database prior to the invention of SQLAlchemy, which is working with raw SQL and even making use of something like drivers and stuff like that, and teach you the concept of raw SQL. When I was trying to cover concepts on raw SQL, that is how I ended up creating like a crash course. It was meant to be 10 minute video, but somehow it resulted to an hour plus video. It was unintentional, or maybe that's how God wanted it, and maybe someone out there needed the video, and I created a video for you guys. So stick around and get the best out of the video. Peace and love. So this foreign key is actually saying what? This foreign key is actually saying that, okay, listen, right now I have my own primary key, which is this ID int primary key. And remember, primary keys are meant to be unique to every single table, right? So that means we can only have a single or a unique primary key, right? But right now it's saying I've got my own primary key, but I want to now also have another primary key in my table or in my space. And whose primary key is that? The user's table primary key. But right now, you can't actually call this a primary key in another person's table. It's like going to another person's country. You are a foreigner in that country, right? So that's what it's saying. I've got my own primary key, but I want to have another column that has some other person's primary key. But right now, I can't call it my primary key because I have mine. So what I can actually call it now is what? Is a foreign key, because it's a foreigner in my own in my own space, which is what? The posts table. Yeah, we know that you are also what? You are also a primary key, but that's in your own word, in our own word, which is a post table label. You are what? You are a foreign key, right? So think of this foreign key whole concept as an ambassador of a country. So what ambassador? It's an ambassador of what? Of the user's table. So this foreign key is actually representing the user's table in the post table, which is what? Another country. So whenever we want to like exchange or communicate with each other, we have to reach out to the ambassador. And what is the ambassador over here? The foreign key, which is what? The user's ID in our what? In our post table as what? As the author's ID. It kind of makes sense, right? So before we connect to our database server, which is we are making use of MySQL, right? We need to definitely put a password. But right now, I'm making use of VS Code to write the queries. On a norm, you are meant to use something like MySQL Workbench, not like on a norm, but like MySQL server provided a MySQL Workbench that you can actually use to like interact with the server. So the MySQL Workbench is like a code editor, but it's specifically for what? It's specifically for writing queries. That's just the difference. But I think there's a lot going on over there, and if you're just a developer, there's no need of making use of MySQL Workbench. You can basically make use of any client, any provider, or like I'm making use of what is called a database client provided by VS Code, which is relatively easy, right? So this is the one I'm making use of to write my queries. You can basically install it. Then after installing it, you can make connections. coming over here, and you see it's very, very easy to make connection. Just put your username, put the port, and put your password, and you connect to your database server. As simple as ABC, right? Or you can basically write from the terminal by just doing my SQL root P, and you put your password, and you could basically do show data bases to see all the whole database we have in our database server, right? So we have blog app, CS3, e-commerce, and flash blog, and blah blah blah. And that's it. Just this how to work on your database using the terminal, right? So we could just maybe use Flask blog, right? And now we could do show tables. And so let's select star. So this select star means select everything from posts. And can you see it's not well presented? So this is one of the major reasons you don't want to work on a large data set using the terminal. So you see, even if you say you should do it like maybe like make use of those /g flag, and yeah, even with this, it's still not really presentable. You can like visualize your data very well. So that's why you need something like a client, like a reasonable client when working on a large data set. But if you're just working on a very small data set like that, you can just make use of your terminal just to get things going, right? So that's basically everything you need to know about working on our database using the terminal. So we can basically log out by just doing Ctrl+D, and we out, and just say bye and bye too, and just clear. So let's come back to our client. So this is where we'll be working on, where we'll be working on in order to interact with our database. So like I said earlier, this is a crash course, meaning we'll be doing everything from the scratch. So I'm not assuming you know anything about SQL queries. So we'll be starting from SQL queries. We'll build SQL queries and do everything ourselves. So right now, let's take off all of this. So if we want to create a database in my SQL server, to be precise, we can write a command that says what? Create database and name of the database. So using this backtick is just conventional, right? So just to distinguish between SQL command or SQL queries with our own regular commands, right? So we can say create database, and let me say tests DB, all right? And if we want to run this query now, we can hit run and we'll execute this query, or we could do control return or control enter to execute this query. But before that, let's basically do what? Let's basically see the database that we have in our server currently. So if we want to do that, we could just write a query and say show databases, right? And if we run this, I will be using control enter in order to execute my query, but you can as well do run over here, right? And now you can see all the whole databases that we have. Look at all the whole databases. And right now you cannot see anything like test DB. Look at, you can't see anything like test DB, right? So if I run this now, it creates what? It creates another database named test DB. So now I can now do show databases, and you can now see the test DB. Can you see it over here? This is the test DB. So it has been created for us. Makes sense? But this is just like a container. It has no, let's say it has no shelf in it. It's just like a container. So for us to add a shelf, we need to add what's it called? We need to add a table. Is it making sense? I'm trying to paint this picture very well. We need to add a table. So think of it like a carton of egg. So like a carton that harbors egg. But you know that carton cannot harbor egg without the egg crates. I think that's a valid explanation. So without the egg crate, so we've created a container. So we now need to add the egg crate that will now specify how we are going to organize the egg, which is a table that's going to specify how we are going to organize the user's data. I never thought of this scenario or this explanation. Well, that's what we'll be doing now. So we've created the container. Now we need to create the egg table, right? So if we want to create the egg table, we have to call a command that says what? That says create table, and we do something like this. So this is how to create a table. Sorry, we forgot the name. So we can now do users. So this is what? This is the users table. But if we execute this query now, how can my SQL know the particular container? Because we have lots of container over here. Look at, we have blog app, we have CS, we have e-commerce. It cannot know. It will not know where to what? Where to create the table. Where to create what? Where to create the egg table. So how can we tell my SQL server where to create the egg table? We need to what? We need to get inside of what? Inside of the egg table. Inside of the egg container, sorry. We need to get inside of the egg container, which is what? Which is this test DB. Is it making sense? So we can actually verify if we are inside of the test DB. Who knows? We might. So if we want to verify, we can write an SQL query and say select database with a parenthesis, right? So what this says is what we are just saying, let's verify what database we are inside currently, and we can run our code, and it says what? Null, which means we are currently not inside of any database. We are just roaming in the streets, right? So how can we tell my SQL server where to create the egg table? We need to what? We need to get inside of what? Inside of the egg table. Inside of the egg container, sorry. We need to get inside of the egg container, which is what? Which is this test DB. Is it making sense? So now we can now say use test DB. Right now we are inside of what? The test DB. But if we even want to know if true we are inside of this use test DB, we can basically do a command that says select database. Can you see? We are inside of the test DB. Is it making sense? We are inside of the test DB. I think I'm going relatively slow, and I don't know how long this video is going to take if we keep going like this. It makes sense, right? So why we needed to use this database is like, so think of it as you having a hotel, right? And you have different rooms in that hotel, and you employ the worker, right? And the worker needed to arrange a particular room. The worker needs to what? Maybe go fix up the bedroom, or like, you know, the bed sheets and stuff like that. So the worker gets to the hotel and sees a lot of rooms. The worker will not know the particular room that you needed to arrange. So how can you tell the worker the particular room? You can maybe probably give the worker what? The key to the particular room that you need he or she to fix up. So that's basically what we did over here. We have lots of containers. If we run this, we have lots of containers. So any query that we are executing, we need to execute it on a particular container. So that's why we need to call use that database. So we did use test DB. So any query will be executing in that particular database. Else the MySQL server will be confused and it will trigger an error. It will raise an error saying no database used. You can try that out and see for yourself. So that's it, by the way. So after that, we can now start what? We can now start setting up our database schema. So it's actually called a schema, right? So we can actually start setting up our database schema. So first of all, I'm going relatively slow. I don't know how long this video is going to take, but that's just because I want you to like understand just like the basic foundations of this. Then we might probably speed up later, right? But this foundation is very, very key to your career as a software developer. So we need to set up the schema of the user. So we know that we are creating the user. So if you want to add a comment in MySQL, you just have to do this. So this is a comment, right? So we are setting up a user. So if you want to set up a user, you have to think of what are the things I need from the user. So basically you are the one setting up. So this is called I think it's called database. I think it's called modeling or something. I've forgotten the actual name, right? So you need to sit down, think of how do I want to plan this in my application? What are the requirements I need from the user? Do I need the user's age? Do I need the user's password? Do I need the user's height? You think of all this. So when you gather all of this information, you can now start setting up the user's schema. It does make sense, right? So before we set up the user schema, we need to put some things in place, and I'll explain why we are doing it, right? So first of all, we need what is called an ID of the user. So we call it ID. Don't worry, we get to see why we need this ID. Then we say ID is going to be a type of integer, right? And it's going to be our primary key. Let's just set up a relatively easy schema, right? Then after this, we have to include the user's name. We need the user's name, obviously, and the user's name is going to be a varchar. Let's just say maybe 50. Then we also need what again? Let me just get your name, and maybe your gender. Let's just get your gender, right? And we say varchar of gender will not be more than, let's just say 20, basically. So this is it. This is just how to set up a schema. So we are saying we need a name, a gender, and that's it. That's basically what we need from the user. So right now we need to execute this query. But before that, let me show you something. So now if we do show tables and we run, so it's meant to be show tables. SQL, like I don't know how SQL used to like give suggestion or like raise errors, because I omitted a S. So why not tell me you missed an S at the end of the like Python gives like a very big hint when suggesting error, and now it's just saying near. I don't know what this means. Like if you know, you can put that in the comment section. But what it's basically saying is because I missed an S, or is that meant to be a S? It does not sound appropriate to my ear. But like I missed putting S, so at the end of the E. So it's meant to be tables and not tables, so I could just see this. And right now it says tables in the test DB. I have no table in the test DB, right? But once we run this query, I think I should be making use of this so you basically see that I'm running something. So right now, if I run this, what will happen? It says the of gender. Okay, sorry, I have to take off this boy. And if I run this again, perfect. Created. So now create table users, and we're done creating it. So like we can now do this show tables again. Can you see? We now have a users table. We now have a users table in our in our database. And if I want to see how this users table is created, I could just do show create table. I don't want to create the users table and run, and this is how the table is being created. So can you see all of this? So this is maybe you're working on a database and you want to know how the database was actually created. You want to know how the schema actually looks like. You can run this command, or you can do the one relatively easy by just doing describe. You say describe users. So just describe the users table for me, so I know how it was being created. So can you see this actually gives a better prompt? So you see it has an ID, which null is no, has a primary key, it has a default of null, has extra, and it has two columns of name and gender, right? So I think describe actually tells about the database schema very well. So before we can start working on our users schema or users table, we've created the users table, right? But right now we can't do anything on the users table because we need we need to write some queries to the users table. So think of it as your television. Before you can get a television to pause, to play, to rewind, you need to write. We need to maybe press some commands on your remote, right? So the remote is like an interface to the television. So that's what we'll basically be doing over here. We need to write some queries to the users table. So luckily for us, our database provider has provided us with some queries that we can make use of when we want to interact with our users table, right? So we have a lot of queries in my SQL or in SQL, but we will not be going over all of them. I mean, there are 1,000,001 queries in SQL. We'll be going over like the basic ones that we work with in our everyday life, right? So we've basically made use of how many, like 1, 2, 3. So we've made use of show, we've used use, okay. We've made use of create, and we're going to make use of a lot more queries in the future, right? So these are like 3 queries over here. So this show query is actually used whenever we want to like inspect a container or like see something. I don't know how to put it, but when we want to see what is inside of a table, a database, we can call the show query. Then we want to get into the database, we can call the use query. Then whenever we want to create a schema we call the create query, right? We have a lot more. We have the select. So this is like the most popular, I guess. We have the select. We have the insert. Don't worry, I'll explain. We have the alter. We have the update. We have the, as the name implies, you should know what it's doing. We have the update. We have join for joining table. We have, I think, select, insert, I will have delete. We have truncate. We have truncate. What again? We have select, insert, alter, update, join, delete, truncate, right? So these are like basic queries. It's way more beyond this. Is like the ones I can remember like offhand right away, right? So these queries, will make use of these queries whenever we want to communicate with our users, with our table, sorry. So let's go over these queries real quick, right? So, okay, before we even select, we need to insert first off, right? So what is this insert method? So this insert query, not method, I mean. So this insert query is actually a query that we make use of whenever we want to insert a record into the database. So whenever we want to take like the collected information, the collected data that we got from any source, and we want to impute it into a table, we can call this insert query by doing something like insert into, and into then table name. So this command over here, then we now have values, right? So this query over here is what we make use of whenever we want to insert a record into a table. It does make sense, right? So this select is when we want to select every single data, every single record in a table. So we call it select query. Then the alter query is when we want to alter an existing table structure. So say for instance, you've created this table, maybe along the line you discover that you needed to add another column, something like maybe an email, right? Maybe an email, right? So you cannot do this, because if you try to execute this query again, if you try to run this query again, it will raise an error saying what? Saying table as already exists. So you can't create a duplicate table in a database, right? So the option is that you can actually drop the, okay, I forgot the drop query. So you can actually drop the table and recreate it again from start. But if you don't want to do that, you can actually alter the table and alter table name, add the column. It does make sense, right? You can use it to modify a column, add a constraint to a column. It does make sense, right? Then the update is basically used when we want to make an update to our record. As the name implies, update. So let's say for instance you want to update your name, you call this update method. So the update query, this query is actually what is being called behind the scene when you want to update your name in an application. So we write this update query to the database and give you access to update your name. It does make sense, right? You actually see this in action, don't worry. Then the join query is used to join multiple tables together. We have the left join, the inner join. I think we'll also have the right join. So we want to join multiple tables because tables have relationship, and which you will see in action, don't worry. So when we want to join multiple tables, we call the join query in order to get records from different tables that we have in our database, right? Then we have delete. This delete query is used when we want to delete a record in our database, as the name implies, delete. Then drop is we make use of this drop when we want to drop a table in our database. So let's say we want to drop this table right now. We could just basically call the drop query and drop this user's table. Basically means like delete the user's table. Then truncate means when we want to delete every single record or every single row and columns of a table without dropping the table, without deleting the table, without altering the structure of the table. It does make sense, right? So these are like the basic queries that you should be familiar with. I think you make use of this like in your everyday life. We have a lot of queries, millions of them, right? But these are like the basic ones that you need to know about and familiarize yourself with. Then aside from that, I think we are good. So let's quickly rush into inserting records. So if you want to insert a record, you could basically call the insert command, and we could do insert, and we say into, then users. So this is how to insert a record. So you can now you have to call the name, the gender, and now you have to now what? You have to pass the values that you want to insert. So this is just the placeholders of what you want to insert. So you now have to pass the values, right? So I can now say the name is what? The name is CS free, and the gender is obviously a male. And that's it. You just have to do this and you insert a record to your database. And if I execute this query again, and I know it was going to echo one error saying field ID does not have a default value. So what does that mean? It means that this user needs a value for the ID, which is the ID over here. I know you cannot cut that. I did not add the ID. Why? So it was intentional to illustrate something to you. But for now, let's just add the ID, and I could just come over here and say that the ID is 1 because it's a type of int, right? If I come over here now and take this off from 1 and maybe do something like this, and and try to run the code and I execute. So can you see it says incorrect integer value for column ID. So this is what are called constraints, right? So we are saying that the ID, we expect that the ID is going to be an integer and it's going to be our primary key. And I'll explain what a primary key is all about. So this is actually defining what this ID is going to be like, right? So we are saying that we need the ID to be an integer. Over here, passing a string right now. So this varchar is basically a string, right? So we could just take this off and now put 1. So if we run this again and do run, but before that, let's try to select the everything in the users and see if the users has a column already, has a record already. So run. So nothing is over here right now. So if we just run this code right now, it says affected rows 1. So it affected just 1 row. Then we could just run this again. So can you see? Perfect. We now have what? We now have a user in our what? In our users table. We now have a user in our users table. Look at the ID, look at the CS, look at the mail. But if we want to insert another user, this code now, watch what will happen. It says well, duplicate entry 1 for key users.primary. So what does that mean? It means that this primary key is going to be unique to every type of user you create in your application. So we've inserted a user with the primary key of 1, and we're trying to insert another user with another primary key of 1, and it says well, duplicate entry. So that's why we mean that this is primary key. So we make use of this primary key to identify a user in our database. And I will explain where this primary key comes in handy along the line. But for now, just know that we use it to what? We use it to identify a user in our database. It makes sense, right? So what we can actually do, we have to change this to 2, change this to 3, and change this to 4. Then if we now execute, fine, execute, fine, execute, fine. So now if we now come over here and hit select, for crying out loud, I'm doing control and I'm hitting enter. That's how to execute this query instead of constantly coming over here to hit the run click or click the run button over here. I don't know, but I find it a little bit difficult for me. So I just let me try and be doing this so you can see what I'm doing. So if I hit this run now, so can you see we now have 4 records? Can you see? We now have 4 records in our database. But I mean, constantly inserting these IDs yourself, it might be very, very stressful, right? So SQL gave us an option. So if we don't want to do this ourselves, what we can actually do is we can actually come here and say auto increment. And simple. So if we do this auto increment, what actually happens is that it gives us the ID by itself. So we don't have to manually keep adding this ID ourselves. So we could just take this off.
Take this off, take this off, and take this off.
But right now, what do you think will happen if I try to insert another record and do something like 5? What do you think will happen? It says column count doesn't match value count at row 1. So what do you think is happening over here? So what is happening over here is that it's saying, look at, this is column count. So this is ID, name, gender. But we're passing the value, just 2 values. We're passing CS and mail. So that's why it's saying column count does not match the value count at row 1. So this is the column count and this is the value count. It does not match. That's why it's echoing an error. But with this, our modification, we expect it to automatically generate a key for us. But it's never going to do that. Why? Because this table has already been created. So any query that you're executing will be making reference to this schema, to this table. So this is the schema that is saying what this is how I need my data, my information coming from you. This is how I want it to be. So you have created this already. So any modification to this, it will not work. What you can actually do, if you try to execute this again, it's going to tell you what? That this table has already been created, and obviously it has already been created. And let's run again. Let's run. It says table users already exist. So that means you need to constantly keep passing the ID. So what you can actually do is what? You have to delete, or you have to drop this table and recreate it again, just for development purpose. During production, there's a way around it which is called migration. I know you might not know what is migration, but you can actually do what is called an alter, and you alter the column and modify it. But right now, in the case of IDs, I think altering IDs might be a little bit tricky because IDs have a lot of things attached to them, a lot of tables attached to them. But I know you can alter every other single column and add modifications to that, or add a new constraint to that. So what we can actually do is we can actually drop this table, and we call drop users, right? So this is basically saying delete the users table. So now if we do show tables, we still have the users table. So before, if I run this command and do show tables again, there is nothing over here, right? So we could just recreate it with this auto increment and fine and good. So this little check means that it ran successfully. So fine and good, we could do show tables again. We have the users table. So right now we can insert. Whoa, what we can do, we have to take this off. Sorry, I forgot. We have to take this ID off because it's auto generating it for us. But aside from that, when this was even there, if we do not take this off, it's still never going to work. It's still going to ask us for the ID, definitely. So if we now run this right now, it's now working, right? So we can now check our table by doing select users. And can you see, it gave us 1 as the ID. It gave us 1 as the ID, but we did not insert any 1 over here. We can run this, fine, and we'll come over here, it will automatically generate the ID as 2. Can you see? It gave us 2 as the ID. So I needed to just like lay the foundations on how we can work with raw SQL. We have a lot of queries going on over here. So you can see that whenever you want to create a new table, you call the create query. If you want to see the tables you created, you call the show. And if you want to select, I guess you call the select query, right? So these are like queries that we can use in order to perform some operations on our database. Come on, this is a very relatively easy what's it called, schema. So schemas gets way beyond this. I'm actually pointing, like you can I'm pointing inside of the screen, like my hand is like the cursor or something. But I mean, it's like a very relatively easy schema. In real world applications, schemas get way beyond what you are actually seeing over here, right? So then we have a lot of constraints that we can apply on our different columns, right? Like our name, the gender, the age, anything, any data or any column that you are modeling in your schema. We have a lot of constraints. And what are constraints? Constraints are like just some requirements that every single column has to meet before we accept it in our database, right? So just for data integrity, security, and performance of your database, right? Because an efficient application, querying data and working with the data should be very, very efficient. You understand? Because you don't want to waste a million minutes just to get a user from the database. So this is why we need some constraint in order to have a very robust database. It does make sense, right? So it gets way more than this, but we don't want to spend the whole night trying to learn about raw SQL. What we're going to do is I'm going to write some queries and I'll explain what they are actually doing, and I'll kind of go into details on how these queries actually work a lot more. So that's everything you need to know, and in the next section we'll actually explain a lot of queries to you, and you see how these SQL queries can get out of hand and the reason you don't want to do that. Hold on. Don't run away. I know there's a lot going on the screen right now. You can actually see a lot of queries over here, right? Don't freak out. We'll be taking it gradually. I will explain every single query over here. Trust me. So let's delve into business immediately. So I said we'll be dropping and recreating database. Obviously, we can actually alter the table. We can actually alter the table and make modifications to the column while we have created the table. But I don't want us to start doing that because it's a little bit advanced, so I don't confuse you. So that's why I said it's a beginner-friendly course, so we'll not be doing that. So get ready to drop and recreate tables. Fine and good, right? So so right now we are going to start creating and and explaining this query. So first of all, let's run this query, which is create database test DB, right? And it just creates a database, and we can actually use the database. I've explained this in the previous video. We can actually use the database, and let's create the users table immediately by running this. Perfect. We now have the users table. So let's run a query that says describe users, so that I can actually explain the constraints over here. So these are called constraints over here, right? So ID, you basically know, is an integer primary key, and auto increment, it just increments the ID for us. The name, I will explain why we have this ID in a short while. Then the name is varchar and not null, and the email is varchar and not null. So do you know what this means? This means that not null, and if we come over here, from the output of the describe user, it says the email nullable means no, and key is unique, and default is null. So let me explain what this is using using our query, right? So now we can actually insert inside of the users table, right? And if we want to do that, we just come over here and run our query by doing run. And right now we've inserted a record into the users table, and we can do this, select star from users, and we'll have a record, right? So what do you think will happen if I take off this email? If I take off this email right here, if I take off this email, what do you think will happen? And execute this query. What do you think will happen if I execute this query? It says, well, field email doesn't have a default value. What does it mean? It means you cannot omit this value. Why? Because of this constraint that we added over here, which is what? Not null. Meaning you must give me a value of what? Of the email. You must give me a value. It doesn't make sense. That's why we say not null. Meaning there must be a value for the email. If we want the email to be empty, which is over here, which is the email, if we want it to be empty, we can basically take off this constraint. And let's drop the database. Let's drop the database. I'm creating. Drop the database and let's recreate again. And come over here and recreate the user. And use definitely and recreate. So I took off the not null constraint. And right now, let me try to run this query. And if I run now, perfect. It worked. It inserted a record. Even with what? Even with the email being present in the schema. It inserted a record, because I'm now saying the email can be null. That means you can actually insert a record without the email. It does make sense, right? So right now we can do select from users. Can you see the email is now null? That's the meaning of what? This the constraint not null. But how about we put back the constraint of not null and drop? Why am I always creating? And drop and use back. Okay, I have to recreate and use back and recreate and come over here and try to insert definitely. And it says field email doesn't have a default value. What does default value mean? Default is also another constraint that we need to know about. So what it's saying is that, so since you're not giving me any value for the email, and the email is saying that it cannot be empty, that means we need a default value. What is it going to default to if you do not pass a value when you're inserting a record in the users table? So what we can do, we can actually call what? We can actually call a default constraint and set it to let me say just cs3@gmail.com. So let's drop, let's recreate, let's create the users table, and let's try to insert a record. So let's insert a record now without an email and see what will happen. Fine and good. And let's try to select the users. So can you see? It now has what? It now has just CS3 as what? As the email. Even though we did not insert any value called just CS3. But we have what? We have a default value over here as what? As a constraint. We have a default constraint over here, which is if there is a value in the user's record, just take it. But if there is not, just default to this. Don't leave it as a null record or as a null column, right? So, but if I come over here now and insert the CS32 into the users table by doing this, and what will happen when we try to select the users? So can you see the CS32 has the email of what? CS32, because come on, it has an email. So don't resort to what? To default. Default is what? Resort. So when everything does not work, I just resort to what? This. That's the meaning of this constraint over here. So I think all these constraints are perfect, right? So this varchar means you're not going to pass any character that is beyond 30 characters. So you can check that out. I'm not going to show you that in action. So I forgot about the unique constraint, right? So what this constraint is all about is that it's saying that two records in the database or in the users table can't have same value for the email column. Does it make sense? So two users can't have same email address in the users table. So that's basically what this unique constraint is all about. So in the real world application, this comes in handy when you want to make sure that every single user has has a unique email address. So two users can't have same email address in your database, right? So that's how you know that, okay, this user already has an account in the database because his email is in our database. So he's not allowed to create another account. Does it make sense? So you can just take this out and just leave this to unique and just drop the database, recreate. So let me just show you how it works and recreate. And if I come over here now and do CS32, so I want to create an account CS32, created, we select. So we can try to run, insert this record again, which is a CS32 record. So we could do command and enter. It says what? Duplicate entry for the what? For the email account. So it detected that this email account has a unique constraint, and now we are trying to insert a user having the same email account again. So it just detects is what? It's a duplicate entry for what? For the email. It does make sense, right? So let's drop this. Let's drop this. Recreate. Use. Then before this, let's then just take off the unique constraint. Recreate again. And just insert this record, select from users. So I took off the unique constraint. That's what I did from the users. So right now, let's see if we try to insert this CS3 to record again, is it going to raise a duplicate error for us again? So let's try to insert again. Fine and good, fine and good, fine and good. So I'm inserting this CS3 record many times, and if I just come over here and do select star from users, so can you see this CS32 records is in our database like plenty of times? Can you see? Because of what? Because we don't have a unique constraint in this our email account. It makes sense, right? So that's how the constraints work. So you can look up the other constraints. We'll have a lot of constraints, so look them up. I'm done with the users table. I'm not coming back over there again. So let's go over to the posts table officially. So now over to the posts table. But I want you to look at the screen for a sec. Can you observe something? Can you observe that some type of column does exist between the two tables? You notice that, right? So you can see that we have the ID over here in the users table, and in the post table we have the ID also. So I'm going to slow down a bit over here because this is very, very crucial for you to understand, right? So why is that so? That's something you should be curious about. That's something you should like ask in the comment section. Why do we have ID over in the users table and in the post table? So don't worry, let me explain to you. So now when modeling an application schema, or when modeling a schema, right, in relational databases, so there is this particular column called an ID that every single table must have. And why is that so? So let me go over, let me like kind of like, I don't know how to put this, but okay. So this table helps us to keep record of what? Of everything that's happening in our application. So this is the users table. So the users table helps us to keep records of what? Of every single user that registers in our application. So this is like a blog application that we are building, and we have the users table and the post table, right? So every single user that registers in our application gets a user record, and we save it in the users table, right? And every single time the user posts a post in the post section, we get the user's post and save in the database, right? That's like the basic way it flows. It does make sense, right? So, but the thing here is that we need to know every single user in the application. Why do we need to know every single user in the application? Because yes, we need to know the user that posted the post. Are you following the drill? We need to know the user that posted the post so that whenever the user wants to delete the post, we can actually give the user access to only delete his or her post and restrict the user from what deleting some other person's post. So that is why we need to what we need to know the user that posted every single post. So before we even start talking about reason why we have this ID going on between the users and the post table, right? So there is even something I was actually, thinking you must have asked in the comment section, which is why did we even have to divide these two tables? Why? Because I mean, we can literally like take this content and author's ID and title and just put them in one schema. So why do we have to divide the schemas and have a separate schema for the user and a separate schema for the post? Which, if you actually thought in your mind, kudos to you. It means that you are what? You are one step ahead of a lot of people because you are thinking, you are asking questions. You must be curious to succeed in this field, right? Always ask questions. Why is this so? Why are we doing this? Why is this syntax? What is this syntax gonna result to? And see your life transform in a short time. So let me explain why we actually divided the schemas. So this divided schema is actually called a normalized schema. And what is a normalized schema? A normalized schema is a schema that we intend, how do I put it? So it's a schema where we kind of organize data in an efficient way to reduce what? To reduce redundancy and dependency. I know this kind of sound a little bit abstract, but I will show you that in practice. So we organize data efficiently to reduce what? To reduce dependency and redundancy. We also go ahead breaking data into smaller related tables and try to establish connection or relationship between two tables or between two related tables using what? Using foreign key. This sounds like a whole lot, but what do I mean? What I mean is that we break down related tables, which is what we basically did over here. We broke down this table, this user and post table. They are related because a user can actually make a post, right? So they are related. So what do we do? Instead of modeling this whole thing over here, we broke them into two parts. That's what we mean. That's what I mean by breaking down related table into two parts and establishing what? Relationship, which is this user table has a relationship with this post table using what? Using a foreign key, which is this foreign key over here. So this is called what? This is called data normalization. So this is actually a normalized schema. Then we also have a type of schema, which is also a denormalized schema, where we tend to bundle every single or related tables or related columns, related tables in one schema, right? What is the essence? The essence is to what? Is to reduce complex queries and reduce joining tables, right? So it just makes querying your database easier, but it has downsides, a lot of downsides, and the downsides are way more bigger than the good side, right? So that is the reason why we go for what? We go for data normalization. So this is actually what? A normalized schema. It kind of makes sense, right? So for me to actually explain this ID, this concept of using ID in schemas, I decided we'll start from this process first off. So if you understand this data denormalization, we can now start talking about ID and you will understand the whole concept a lot better. So for that reason, I created a separate workspace which I titled denormalization.sql, where I've already created some queries so that we can use to illustrate what I meant by data denormalization. So over here, we are basically still making use of our test DB. Don't worry, we'll still get back to our original test DB. Then we have a table which is called users and post table. So if you notice over here, you see that we bundled what? We bundled the name, the email, the title, the content coming from what? coming from the post table, we bundle them together. So we just have one table for our blog application, which is the name, the email, the title, the content. So this is called what users and posts table. So I want to illustrate why we don't make use of this denormalized schema, right? So what we can actually do is we can actually just create this. We actually just have to drop and recreate. Then let me create I'm hitting command and return, please, just in case you're not aware. You can actually make use of this drone, but I feel the shortcut is actually way more better. So I'm hitting, look at my hands, I'm hitting command and return. I'm on Mac. So let's use the test DB. Then over here I can do I can run this. So this late check means it's executed successfully. So now we could show the tables. So look at the table that we have. We have users and posts table, right? So right now, if I want to insert a record, I can insert the name of the user, the email of the user, the title, and the content of the post the user want to post, right? So basically, let's insert this post over here. Let's insert this record over here, sorry. So this is the record. So I'm just inserting the name and the email. What does this mean? It means that, so for instance, you go to an application, you register a blog application and you register in the application. But right now, you've not created any post. So that means your post table is going to be empty, or your post column is going to be empty. So that's what I'm denoting over here. So we have a user called Alice who just registered in our application, but she has not yet made any post, right? So I just have to insert the user and I just run. So let's check, fine and good. So let's select the post table, the users and post table. So watch over here. So you can see that we have the name, email, title, content, and created that. But now we only have Alice and her email and the title of her post is null and the content of her post is null, which basically means she has not posted anything in the post, in the post section, right? So that's why both the title and the content is null, obviously. So now let me now show you something. So how about Alice tries to create another post, like tries to create a post in what? In his or her account or in her account, right? And this is the records Alice wants to insert, right? So this is insert into users post and blah, blah, blah values. So then I now hit enter. Alice now what? Alice has created a post, which is Alice post 1 and content of the post, right? And now remember that Alice has to give us her email and her name every time she wants to create a post. It does make sense, right? Then now if we query our database, can you see what just happened? So right now we are having duplicate entry for Alice in our database, which literally makes no sense. Because that means every single time Alice creates a post in our database, in our denormalized database, what will happen? We will keep receiving Alice record every single time. And maybe somewhere in your mind, you might be like, there's no problem with that, but there is a big problem and a big challenge with this type of what schema. And I will open your eye to see that, right? So now let me show you one very big downside of this schema, of the normalized schema. So first off is that we now have duplicate entry for Alice, which is very, very bad. And look at the first instance of Alice, or like the first record of Alice, the title and the content is forever going to remain null. Why? Because at this instance, she never created a post. So this is ever going to remain null in the database. And this null is not like a place value. This null actually takes up some bytes of memory in our server. In some database providers, this null value actually takes up some memory. So that means now we are consuming much memory than we need. Which, as a software developer, you should know how to economize your memory, because memory is very, very expensive. So this schema has failed us in terms of what? In terms of managing our memory. Let's you want to do what? I don't know how you want to do it, because you don't want to tell me that you can write some query and check if the title and the content is null. You can basically update it with the recent value she created. If you do something like that and now take this Alice post 1 and take over here and take this is also going to be null. And aside from that, the timestamps will not match, because this was created at this timestamp and this was created at this timestamp. So if you take this value and put over here and take this value and put over here, that is data inconsistency, which is what you don't want to do in a database. A sharp and a solid database is a database that offers data consistency and integrity, right? So if you should take this value and place over here and take this and place over here in order to cover this null or replace this null values, there is data inconsistency. Come on, the timestamps do not match. It makes sense, right? Which you will never even have to try. But just, I'm assuming even if you want to do something like that. So you see that this database schema has failed us in terms of what? In terms of managing memory, data integrity, data inconsistency, duplicate entry, which is this Alice now has duplicate entry in our what? In our database. But now you might be like, what is the downside of this duplicate entry? Let me show you. So let's say Alice inserts another post again. And let me just take this off and get this to be this Alice. And let me insert again. And let's run our users. So this is 3 posts coming from Alice. And let's insert a post from Bob. Look at Bob. Let's insert. And now let's execute. So we now have Bob record inside of our post. So what do you think will happen? Because in our application, we can actually update our email account or update our name. So let's say, for instance, Alice forgot her email password and wants to make an update to her email and maybe change her email or something like that. Just she wants to change her email. So you know that whenever you click change email, we have to write a query to the database and update your email on the fly. So everything you're doing is basically interacting with the database. It makes sense, right? So immediately you hit enter, what will happen? We, the developers, we're going to write a query to your backend, to our database, and update the email in our database. So we'll basically write a query like this, which is update users and post, set email, which is we are getting the new email, so we are just simulating that this is the new email you want to change. So this man will be email is equal to alice@example.com. So we want to update your email, right? So we could just hit perfect and good. But do you know what will happen? What is going to happen over here is that this query, look, watch what happened here. It took 7 milliseconds. You know where, right? You know where that these are queries. Anything any operation you want to carry out on your account, it's what? It's time based. That's why when you want to retrieve all your posts or the posts that you posted like years ago, they have to write a query to the database. And come on, imagine it takes like 2 minutes to get your post for you. Will you wait? You will not. You will get tired. So that means this query took 7 milliseconds, which at this instance is very tiny, right? But imagine we had like billions of users, and this Alice is duplicated billions of times in our application, in our database. That means that this query is going to run every single time from 1 to any amount of time that this Alice appears in that very large data set and try updating the value. It's going to take a long while. And that's why you don't want to do that. Right now, if you run this query, yeah, it has updated to updated alice@gmail.com. But this is redundant data. Because why do we have to keep updating it having this email account multiple times? We can just have it one place. So that whenever Alice makes a change to her email, we can just update it at one place. We don't have to constantly updating it every single place. It does not make sense, right? Look at this is a very small data set, and you might not even notice that it took a long while to. You might not notice the impact of this redundant data, right? But let me show you where we'll have like a very large data set. So imagine we'll have a data set like this. So this is like a very large data set. Not even large, but like at least it's a large data set. So this is actually inserting into a table called temperature. Look at it over here. So insert into temperature. And you see, these are like thousands of data, thousands of records. So start thinking of big companies like Amazon that has millions of users in the application, and you want to update your email in such an application and it's duplicated all over the database. It's going to take a very long while to perform that operation, and which will reduce the efficiency of our database queries. So can you see that we've actually more than 5 problems that this type of database schema can actually pose. Is it making sense? Let me now show you the last example and we're done with this. So let's say, for instance, because in an application, multiple users can have the same post title. Of course, you can post a post with maybe updates on Spider-Man, and I can also post a post with title of updates on about Spider-Man, right? So I can actually go over here. Let me try to insert another record of Alice, and let's say the post title is update on new video. Let's just call it update on new video. Then let me copy this and come over here to this is like the Bob record, right? And Bob also posted a post titled update on new video, right? So let's execute this and try to select from users. Okay, look at it. Alice and Bob currently have what update on new video. So let's say now Alice wants to what update the title of our post, right? So now we can come over here and write a query and say what? And say, please subscribe. So this is me what? This is Alice updating what? Updating her title, her post title, right? Then I can say where title is equal to what? Is equal to update on new video. Because that's the title of her post. Look at it, update on new video. That's the title of her post. Then let me now update her what? Her post, her post title. And I hit enter. Then I come over here and try selecting. Can you see the magic that just happened over here? So Alice wanted to update her post title from update on new video to please subscribe. But what will happen? Bob's post title was also updated. Why? Because Bob also had same post title as update on new video, just as Alice has. So when we wrote the query just went to the database and saw two posts having same title, which is update on new video, and did what? And updated the both records to what? To please subscribe. The both title to what? Please subscribe. So now we are updating Bob's post title without his consent. So this is why you should not model, we should not have a denormalized what? A denormalized schema. So a denormalized schema tends to what? Pose a lot of issues. Makes sense, right? So this is, oh, my fault. I actually even forgot to like make it clear. So just in case you don't know, this is the way we make an update to a table column, right? So you just have to make reference to the table you want to make update, which is users and posts, which is the name of the table that we want to make update to, and you have to make now select the particular column that we want to make update to, which is the title. So that's why we said what? That's why we said update users and posts, set title equal to the new title that you want to set, where title is equal to the previous title you had before, right? So I think this is like pretty clear how this update query actually works. Is it clear? So you know what we can actually do? Let's even say right now we're not assuming that Alice is the only person that has the title of update on new video, right? So let's kind of take that out of the way and make reference to Alice's name, because you can actually say set title where name is equal to Alice, so that we just make sure we are only hitting Alice's record, right? So what we can actually do is we can say update users and posts, set title equal to, let's set another title, which is please make sure to like, comment, and share, right? So we are updating the title from please subscribe. Look over here, which Alice has please subscribe. So we are now updating it to please make sure to like, comment, and share. And we are setting it to where? We are setting it to where the name of the user is what? Is Alice. So look at what we can do over here. We can say where name is equal to what? Is equal to Alice. So these are what? These names over here are what? Alice, Alice, Alice. So what do you think will happen over here? Because right now we're just trying to make sure we don't tamper with some other person's record. So now we're making use of the name as a reference to what? To the column that we want to update. So any place it says Alice, it will update the title. So right here we have Alice with the title of what? With the title of content 1, Alice with the title of content 2, and Alice with the title of please subscribe. So if we run this query, what do you think will happen? This query is going to update every single title over here. It's not only going to update the please subscribe, it's going to update every single title coming from Alice. And let's check if that's true. So if we run this query, I'm hitting command and return, or you can make use of the run button. So now we've updated it. Let's select again. And that's it. Can you see what just happened? It did what? It updated every single title coming from Alice. Because Alice has duplicate entry over here. It does make sense. Look at first Alice, it updated this title. This was actually no before. It set it to please make sure to like, comment, and subscribe. Over here, Alice had a title of content 1. It updated it to this. Over here, it updated it to this. Then the last place where he had please subscribe, it updated it to please make sure to like, comment, and share. Which you should actually do if this video is actually helpful to you. So do you see the problem with what? The problem we face when working with what? Denormalized schema. So this is the reason we introduced what? We introduced the normalized schema, which is where we have to break down data into related tables and make what? And make relationship or connection using what? Using foreign keys. And that's how we are able to solve this problem that we faced during the days of what? The normalized schema. There might be places where you might need the normalized schema, but I think when modeling a very large application, you should go for the normalized schema. It kind of makes sense, right? So let me now show you how we want to solve this problem using what? Using a normalized schema. So welcome to the normalized schema, right? So I named it normalized schema. So let's now understand why we have to divide our tables into what? Into like smaller tables and kind of like make use of what is called foreign keys to what? To link up the two tables together, like create a relationship or a connection between two tables, right? So do you know what we can actually do? So we are trying to know the reason or understand the reason why we make use of IDs to identify a table, right? Or to establish relationship. So, but do you know what we can actually do? Let's first of all take off these IDs and see what was actually the real problem and why we resorted to making use of IDs, right? So first of all, let's just take off the IDs. Let me show you something. So I took off the ID from the users table. Look at it over here. So this is what I did. I took off the ID. Then I will just take off the ID also from here. Take off this ID. Take off this foreign key. So let's just see where the problem started from. So can you see? Now we've just taken off all the whole IDs over here. So we just have literally a simple schema, which in the user schema, it harbors the name and the email of the user. And in the table, in the post table, it harbors title, content, and the date the post was actually created. Very, very simple and straightforward, right? So what we can actually do is we can actually create a database. I think I dropped this database. So let's just drop and recreate. So this late check means it's executed successfully. And now we have to use the database. Then let's create the users table. So we'll create success. We'll create. I'm having that. Okay. It's because of this comma over here. I just have to take it out and execute. And perfect. So that's everything we need to do for now. So we have created the users at the post table. So right now we could just come over here and do show tables. So can you see we now have two tables, which is post and users. We can go ahead and do describe users. You see we only have name and email as the columns. We can do describe post. We have in the post table we have title, content, and created at. Very, very straightforward, right? So what we can actually do now is we can actually start inserting records, all right? And I assume you know that this is the way we insert records. So we just do insert into the table name we want to insert, and the columns we want to insert, and the values, right? So we got values and the whatever we want to insert into the column. So that's basically how we insert into records, right? So what we can actually do, let's insert a couple of records for the user. So this is, we are inserting in the user's record right now. So we can just insert, okay, I need the email field. So I could just say cs3one@gmail.com. So fine and good, we insert this record, see fine and good affected rows 1, and we also insert, let's just insert 3. So fine and good, now we now have 3 records for the user table, right? So let's select start from users. So can you see, we now have 3 records. So just stay with me, I'm trying to build up the whole explanation properly. So look at, we now have 3 users in the users table, which is CS31, CS32, and CS33 in the users table, right? And their corresponding email address. So right now, let's quickly insert into what? Into the post table. So we just have to come over to the post table. Right now, we have to take off this author ID, because we no longer make use of the author ID column, right? Don't worry, we'll still get back to it in a short while. We'll have to just take this off and also take this off. Okay, so let's just insert. So fine, right? So we've inserted 3 records into the post table. So let's select everything from the post table. And this is everything from the post table, which has post 1, post 2, post 3. And the content is just a random post. Please subscribe, make sure to like, share, and comment, right? And right now we have 2 different tables, the users and the post table. Now, we are assuming that every single user in our application is the user that actually posted these posts. But now, here lies the challenge. How can you determine the user that posted this post? Because we have a separate table for the user. So this is just random posts inside of what? Inside of the post table. So right now, you can't tell the user that owns this post. So let's say the user wants to make an update to the post. How can you determine that the user owns the post 1 or the user owns the post 2? You cannot determine that because there is no column that denotes or that specifies this user that made the post. So that is the challenge. So how can we fix that? We can go a very lame way, which you might think that is efficient, but I will show you. I will open your mind to see the downside of going through the route, right? So what we can actually do is that we can actually include another extra column over here and call the extra column what? The author's name, which basically means the name of the user that made the post. So whenever the user wants to make a post, he has to include his name in the column. Makes sense, right? So we could just quickly rush over here and drop the database and recreate. Then come over here after our users table in the post table, we just have to include another column called what? Author's name, right? Let's just make it a varchar of maybe, let's say, 100 and not null. So it's not nullable, which means we must include the author's name so that we can know the user that made the post. Makes sense, right? So let's just quickly create no database selected. Let's select, recreate, and we just now have to insert a couple of rows in the users. And over here now, so we've inserted a couple of rows in the users. Let's just select and be sure. So right now we have 3 users. So over here, now what we can actually do is we can actually insert into the post record, right? But now we now have to include what? We now have to include an additional column which specifies the user's name. So now we are saying that this first post was made by the user CS31, right? Look at the user over here. So we now have to include his name, which is CS31. We now have to include it over here. Then let's not forget to add our name, its name, author's name, right? Let me see the spelling. Author's name. So we now have to include the author's name over here, right? So I forgot the T. We now have to include the author's name for this name over here. So this CS31, this means this user over here. So this user made this post, and we just have to do that for subsequent users. So we just have to say CS32 and CS33, right? So let's just quickly insert success. So now we've inserted 3 records, which is CS31, CS32, and CS33 in the post table, right? So now we can just quickly select the post table. Perfect. So can you see right now it's very clear, and you can actually now visualize the post table very well. So you can now you can actually know that the first post was made by CS31, by the user CS31, and the second post was made by the user CS32 and the rest, right? So right now we've established a relationship between the users table and the post table, because right now in the post table you can actually identify every single user that made the post in the post table, even if they are separate tables. But right now you can still know the user that made a particular post. So do you see we've solved the problem? So what is the essence of this? The essence is that we now have two separate tables. So we are not coupling this post table and the user table in one table. We now have separate tables. But this also still has a downside. And what is a downside? The downside now is, how about the user tries to update his name? What can happen? So let's write a query real quick. We could say update users. You say set name equal to only CS3, where name is equal to CS3.1. Can you see what we are doing? We are trying to update the name of what? Of the first user, which is CS3.1. So the CS3.1 wants to update his name. Maybe I don't want to answer CS3 name. It's a username. I can change it to whatever username I want to answer, right? In the application. So right now, let's execute this query. So we execute. And CS3.1 has updated his name to what? Only CS3.1. So right now, we could verify if that's true by selecting this. And look at it, has updated from what? From CS3.1 to what? Only CS3. What now is the problem? The problem is that in our post table, we still have a user that made a post titled what? Named what? Named CS3.1. And let's verify that. So can you see? The author's name in the post table is still CS3.1. But the author has already updated his name in the users table. So what is now the problem? The problem now is what? Data inconsistency. So if a user should update his name in the users table, we have to also update it in the post table, which is what? Additional query. So we have to keep running multiple queries anytime an update occurs in any single table, which makes literally no sense. And over here, this is a very small application. Imagine a very large application. We might have thousands of tables linked together using what? Using the author's name. So that means if the user should change his name in his users table, we have to run a query and change his name in every single table that has a relationship with that user, which is what you don't want to do. So this is where the problem actually lies in. So how did we solve the problem? That is where we now introduce what? The use of ID. So now we've seen the reason why we don't make use of author's name when establishing relationship between two tables, right? Or any other column aside from ID while establishing relationship, right? Reason that column might change in the future. And if it changes, you don't want to keep updating it everywhere it appeared in your database. It makes sense, right? So that's why we make use of what is called a unique identifier, which is what? ID. So we can make use of the ID to uniquely identify every single record instead of what? Instead of making use of the name. It does make sense, right? So what we can actually do now is we have to just take off this author's name and link the tables up using an ID. So we just have to add an ID over here and say the ID is int, and we have to make the ID to be a primary key. So why do we have to call it a primary key? So this primary key is like a constraint provided by my SQL. So what this means is that this primary key is going to remain unique to every single user. And we can't have the same ID duplicated in what? In your database. So this is like a way to make sure that this ID is unique. So if you insert a user with an ID of 1, that's the only user that's going to have an ID of 1. You can't insert another user with an ID of 1. So what has this primary key solved for us? It has helped us what? Eliminate duplicate entry. So that's what the use of this primary key constraint. All right? Then in the post table, we can actually also do what? We can also add the ID, call it int, and also make it a primary key. Primary key. Right? So perfect. We now have IDs over here. So how then can we establish relationship? We can now establish relationship making use of this ID. So instead of now referencing the author's name over here, we just have to add another ID and call it what? And call it author's ID is equal to int. Are you catching the drill? So now we want to make use of this ID to establish relationship instead of making use of the author's name. So now we are now defining a column called author's ID that will now, this column is now going to be like the author's name. So this is now like author's ID. You following? You following, right? So what we can now do is we can now come over here and now create another and now try to establish the relationship. So how can we establish the relationship when we are working with ID? We have to call this foreign key command over here, and we now say foreign key is equal to what? Is equal to author's ID. Are you following? So I'm coming. Is equal to what? Author's ID. So this foreign key is actually saying what? This foreign key is actually saying that, okay, listen, right now I have my own primary key, which is this ID ain't primary key. And remember, primary keys are meant to be unique to every single table, right? So that means we can only have a single or a unique primary key, right? But right now it's saying I've got my own primary key, but I want to now also have another primary key in my table or in my space. And whose primary key is that? The user's table primary key. But right now you can't actually call this a primary key in another person's table. It's like going to another person's country. You are a foreigner in that country, right? So that's what it's saying. I've got my own primary key, but I want to have another column that has some other person's primary key. But right now, I can't call it my primary key because I have mine. So what I can actually call it now is what? Is a foreign key. Because it's a foreigner in my own what? In my own space, which is what? The posts table. Yeah, we know that you are also what? You are also a primary key, but that's in your own word. In our own word, which is a post table label, you are what? You are a foreign key, right? So think of this foreign key whole concept as an ambassador of a country. So what ambassador? It's an ambassador of what? Of the user's table. So this foreign key is actually representing the user's table in the post table, which is what? Another country. So whenever we want to like exchange or communicate with each other, we have to reach out to the ambassador. And what is the ambassador over here? The foreign key, which is what? The user's ID in our what? In our post table as what? As the author's ID. It kind of makes sense, right? Then we can now say what? We can now call this and say references what? References the user's table. User's table. This references is what? Is making reference to the user's table. So where are we going to get the ID? We're going to get the ID one from the user's table, not any other table. So that is what these references mean. I know it's a lot more. That's SQL for you. That's why people opt for what? Object relational mappers. That's the syntax of SQL. You have to just know these, right? And get it stuck in your brain. Then after these references, we're not done yet. We're still going to add what? We're still going to add another parenthesis. And this is the last we have to do. We now have to pass what? We now have to pass ID. So what does this mean? It's saying references the user's table, or this is just the user's table. In the user's table, what column do we want to reference? We want to make reference to what? We want to make reference to this ID over here. That's what we meant by this ID. Is it clear? So I know this line is a lot more, just like try and go over it again and again and again, and it's what gets stuck in your head. You don't even need to cram it. Just understand the logic over there. You might forget the syntaxes, and you can always Google and get the syntax and get it over there. You feel what I'm saying? So this is basically how to what? Establish relationship. We have a foreign key. What is the foreign key? The author's ID over here. And the author's ID is going to hold the value just like our author's name. And it's going to make reference to the user's table over here. And in the user's table, what column are we making reference to? We're making reference to what? To the author's ID. So any value in this author's ID is going to, in this ID of the users, is going to be over here in what? In this user's ID. Is it clear? So that's how to establish relationship between what? Between two tables using what? Using a foreign key instead of making use of the author's name. And right now we could go ahead and start inserting tables and start inserting what is it called? Records, right? So what we have to do, we have to basically drop this database, recreate it again, use, create. So I forgot to tell you, so this if not exists just helps us to if you're familiar with condition of this, if not exists, creates something. So if this user's table does not exist already in our database, just create it. But if it exists, don't raise an error. Look at, if I hit it now, it's not raising an error. But how about we take it off right now and drop this and create it again and use and create this table. So after creating it, if we hit it again by mistake, it's going to raise an error saying table users already exist. So we don't want to keep getting this. That's why we just make use of this if not exist. So we have to drop, create, use. So right now, if we create this table, created, if we hit again, it will just ignore us, meaning what? It has already existed, so it's not going to do anything again on the database. You understand? So let's just create this table. And I have an error. So what's the error? So I have to add a comma over here. I always forget this. So we hit this and perfect. So right now we've established a relationship. So right now, what can we do? Let's just quickly insert records. Email field ID doesn't have a default value. Oh, so this ID is meant to be auto increments. I forgot that. Auto increment, so that it generates it for us. We don't have to keep doing this all the time. So let's quickly drop, recreate this, and right now we could just insert this. Perfect. Look at the lead check. Perfect. Perfect. So right now we have 3 users. So let's try to see the users. So can you see? We now have 3 users. So now we now have an extra column called ID, which is unique, a unique identifier. So right now we just have to insert records in what? In the post table. So we just have to go to the post table over here. So what can we now do? So tell me, guess. What can we now do in order to insert record in the post table? You have to tell me. Okay, so what we can actually do is what? We can now actually have to change this from author's name to what? Author's ID. Because obviously we're now making use of the author's ID and not the author's name, right? So we just have to what? Pass the ID of the author. And how can we do that? Over here we can see that we have an ID of 1, 2, 3 for the word for CSV 1, 2, and 3, right? So that means we have to pass 1 over here, right? And if we execute success, so over here we just have to pass 2, and over here we have to pass 2 and execute. Oh, sorry, I have to pass author ID. I know you got that 2, and over here author ID, and we'll have to pass 3, and that's it. So we just have to insert this, and let's select start from post. So can you see? So now we now have author's ID of 1, 2, 3 coming from what? Coming from the users table, which is where they had their ID, which is 1, 2, 3. So now we have established a relationship between the 2 tables. Using what? Using the author's ID and not the author's name. And let me show you the essence of this foreign key constraint, of this foreign key column over here. So the essence of this foreign key. So let me now show you something. So you remember that we have what? We have 3 users only with the ID of 1, 2, 3. So now let me try to insert a record in the post table with an ID, with an author's ID of 4, which does not exist in the users table. Look at over here in the users record, we don't have any record with an ID of 4. The record's ID stopped at what? Stopped at 3. So we are trying to insert a record in the post with an author's ID of 4. And let's see what will happen. So right now, if we execute our code, it says what? Cannot add or update a child row. A foreign key constraint fails. And what is this big English? It's saying what? Look at the constraint over here. And it's saying foreign key author's ID references user's ID. And what is this whole big English error? So what this is saying is that what? Remember that when you try to set a foreign key, you are saying what? That any single post I will make in the user's post or in the post table, before you establish the relationship, make reference to the user's table ID. You understand? So that's why we're making reference. That's the reason of these references. So that means anytime you want to insert any record in the post table, it has to check if this ID is currently present in what? In the user's table. So if when you inserted the post 1 with an ID of 1, it did what? It made reference to the user's ID, and it saw that okay, yes, there is a record with an ID of 1. It said okay, you can insert. And it allowed you, you did that. When you did 2, it checked, okay, there is 2. When you did 3, it checked, okay, there is 3. And when you try to insert a record in the post table with ID of 4, which is coming from the user, so it checked the user's table and it wasn't able to find what? A record with an ID of 4. So that's why it now echoed an error saying you can't insert a record with an ID of 4. But right now, if we go to the user's table and insert another record, so let's come over here, CSV4. And now select everything from the users. Now we now have 4 records in the users table. Look at CSV, the fourth ID, right? So let's now try to insert a post with an ID of 4, and let's see what will happen. And we'll hit enter. So can you see? It now worked. Because why? When you try to insert the record, it went to the post table and it saw an ID of 4. And it now said, okay, there is an ID, you can now insert. So this makes sure that there is no duplicate entry and there is no record in the post table that does not have an owner. So that's why we make use of this word. This what's it called? ID to what? Establish relationship. It makes sense, right? So this is how making establishing relationship using the IDs work. And let me now show you another interesting thing. So over here, right now we can now update the name, right, of the user, and it will not affect anything. But before we even do that, let me show you something. So right now in the post table, let's try to update the user's author's ID from 4 to 10, which is over here. So let's select the post and say posts. So let's try to update this author's ID that is 4 to 10, and let's hit enter. So can you see it says what? Cannot add or update a child row. And what is a child row? So a child row is any row that has what? A foreign key relationship between another table. So that is a child row. So over here, this is the post. Any row in the post is a child row, and any row in the user's table is a parent row. So in the child row, there are some constraints coming from the foreign key, which is what you cannot add. And what is this add? This add is when we try to add a record, a post record with an ID that does not exist in the user's table. That's what it means by you cannot add. So what does update mean? Update means that you cannot update the author's ID coming from the user's table. That's why it says cannot add or update a child row. Then what now? Let's try to update the ID to 10 where the user's ID is 4. Let's select the users over here and watch. So we're trying to update this ID from 4 to 10. So let's hit enter. So can you see what it says now? So over here it's saying what you cannot delete or update a parent row. We'll still get to this delete, what this delete means. But let's talk about updates right now. So this is a parent row because this is the row that gave the child row a key, the key, which is the ID that the child row made use of when it established the relationship, right? So right now it's saying you cannot update the ID. It does make sense. That's what update a parent row means. Over here it's parent row, and over here it's what? It's child row. In the post table it's child row, and in the resource table it's what? It's parent row. We'll still get into proper detail about this delete. You see where this ID comes in handy because it has a lot of securities to ensure what? Data integrity in our table or in our database. So that is why we establish relationship using ID. So let's quickly do what? Let's quickly even just update the name of the user. So over here in the update user, we can just say set name to what? To only CS3, where name is equal to what? Is equal to CS3 1. So we are updating this name over here to what? To only CS3, and when we hit enter, I have a problem. So update user set name equal to only CS3, where, so what is my problem? Update user set name to only CS3, where name is equal to, there should not be, I don't even know what was the problem, but it's working right now. So update user set name equal to only CS3, where name is equal to CS3 1. And right now, if we run our select star from users again, so right now the name is saying from CS3 1 to only CS3. And what is the benefit of this? The benefit of this is we don't have to run an additional query to the post table. And if we go to the post table, we don't have to update anything over here. Why? Because the ID is still same. The author's ID coming from the user is still the same. Over here in the users, can you see the ID never changed? We just changed the name. And if we go to the post table, the ID is still what? It's still same. So there is nothing like duplicate. So we just updated the name. And nothing else, we don't have to do any other thing to the tables. We just updated the name in the users table. That's not what the post table is making use of when it established its relationship. It's making use of the author's ID. And right now the ID coming from the user is still same. So there is no need for an additional query. So with this relationship, we've seen the way that we help to eliminate duplicate entry of any record in both tables. So you can now see that establishing the relationship using the ID is a perfect way when it comes to normalized schemas. So that is how we do things over here. You now see how everything works between the denormalized and the normalized schema and how we construct and build our SQL. So when we now start talking about object relational mappers, it will be relatively easy for you because now you have a great understanding how these SQL queries work. Because in object relational mappers, you will still be what? You still be modeling tables. You still need to what? Add some constraint. So that's why I had to pass through this route so you understand so well what is actually happening during the in the world of SQL. So when we now go over my object relational mappers, what it will be very, very easy for you what to navigate. So the last thing I intend showing you guys is what? Deleting a record. So right now, if you want to delete a record, you could just basically do delete from uses, where name is equal to what? Is equal to, I think it was only CS3. Let's verify and let's come over here, copy, paste, and let's select start from users. So yes, so we want to delete this record over here. Let's delete it from our database. So say you are in an application, you want to delete your account. That's what we want to do over here. So let's hit enter. So that's what it said. Well, cannot delete or update a parent root. So this is the delete we're not talking about. So what is the constraint over here? So the constraint is saying that you cannot delete this record. And why? So the reason is because this record has an entry in the post table. And look at the ID of the record is 1. I remember that in the post table, we have what? We have a post that is coming from the author's that is coming from the user of what? Of ID 1, which is this author's ID. So it's now trying to tell you that, hello, if you delete this user, who is now going to own the post that you posted what? In the post table? Absolutely nobody. So it's going to become what is called what? An orphan record, meaning that the father is dead. You cannot cut the drill, right? So you can't delete the record. So say you have this kind of an application or this kind of database modeling in a real world application. So that means if you post or if you make a post to the blog and maybe at some point you got fed up of the application, you can't leave the application, because if you leave, who will now have possession of all the whole posts or all the whole posts you made in the post table, which totally makes no sense because you don't want to hold me hostage in your application. If I want to go, I can go, right? So it's not really that we are interested about you leaving our application. I mean, we might be interested in your presence, but the thing is that we are much more concerned with on our memory, because I mean, those are your data that we are keeping for you. We are keeping them permanently. We are storing them for you. So now, if you want to leave, just do well and leave with all of your data. Because if you don't go with the data, it's going to take up what space in our memory, and what hereby reducing the efficiency of our the performance of our database. So we are not allowing you to do such. So if you are leaving, just make sure you go with all of your data. It says right. So that's the whole thing. But hold on, did I just say I don't need you in my application? Please, I was kidding, man. What did I just do? Well, I went out of character. I was trying to be a little bit cocky right now. I'm kidding. Let me say the honest truth. So forgive me for that. Don't leave our application. We really, really need in this application. I mean, how can we grow without you? Don't leave. Forgive me. I went out of character. So the truth of the matter is that if you leave the application and your post is still present in our post table, it's going to compromise the integrity of our database modeling. What does that mean? It means that every single post in the post table with what we modeled, that means that every single post in the post table is owned by a user. That's what the foreign key constraint actually means. It means that any single post in the post table must be owned by a user. So if we should delete a parent record that has a post in the post table, that means that this post will now become an orphan. And becoming an orphan means it's not owned by any person in the user's table or in the user application or in our application. Hereby corrupting the modeling of our database. And aside from that, I mean, your post is going to become an orphan. Are you this heartless? I know you are not. So you know what? Stay back and don't leave the application. It makes sense, right? So that's everything you need to know about this whole on delete. You can't delete the parent, or you can't update the child. Makes sense, right? But let me now show you one thing over here. So you know that now we have 3 posts and we have, I think we have 4 users, right? So we have 4 users. And in the post, we have just 3 posts, which is coming from the 1, 2, 3. So that means that the 4th user has not posted anything. What? In the post table. Does it make sense? In the post table, right? So let's try to delete the 4th record, which is the 4th user, and know if it's going to still echo the same error. Remember that when we try doing this, it's saying no, because this is only CS3 and the ID is 1. So right now, let's change it to what? To CS3 4, which is this 4th user that has not made any post in the post table. Look at right now the CS3 4, which is the ID, 4th ID, or let me just do ID so you kind of understand. Perfect. ID is equal to, let me say, 4, right? So like right now, if we select the users, look at the ID 4, and in the post, we don't have any ID like 4, author's ID, we don't have any number like 4 over here. So right now, if we try to delete this user, let's see if it's going to echo an error. But first of all, let's try to delete the 3rd user. So if we try to delete the 3rd user, it's echoing the error, which is cannot delete or update. Look at, we're trying to delete this ID 3. So right now, let's change it to 4. This 4 does not have any post in the post table unless what's going to happen. Perfect. It's affected 1 row, right? So now let's select the users again and see if this user is going to still remain in this database. Unless, can you see? The 4th user is gone. Why? Because he does not have any post in the post table. So now you are what? You are free to go. It makes sense, right? Now you are free to leave the application because you don't have any post in the post table. But if you got a post in the post table, you must remain permanent in that user table. But if you want to fix this whole issue so that whenever you want to leave, you can leave, what can we do? We have to add a little bit of tweak in what? In the database schema. So we just have to go over here and come to this foreign key. In the post table, we have to add what is called on cascade delete. Why do I have delete? And on updates cascade. And I will show you what this means in a short while. So let's drop the database, recreate, use this, what's that near cascade? What's the error? On delete, I know you saw that, on delete cascade and on update cascade. So let's run again. Perfect, it worked. So right now let's quickly insert records, insert, and insert. Then let's insert in the post, insert, right? So let's select the post. So we have 3 users in the post, and let's select 3 posts in the post record, and let's select from users. So right now we have 4 users. So in the post table, the first user, which is author ID of 1, has made a post, author ID of 2 has made a post, and author ID of 3 has made a post. Right now, let's try to delete the user 1, which currently has a post in the post table, and let's see what's going to happen. So let's delete. Perfect, right? So right now we've deleted what? We've deleted the first user, which is the ID of 1. And right now, if we select the user, so can you see? The user with the ID of 1 is now gone from our database. So now let's see the shocking magic, right? So let's select the post table and hit enter. And now what happened? The post coming from the user 1, which is the user that has an ID of 1, is now ripped out of what? Ripped out of our post table. Why? Because the user is no longer in the application, so it makes literally no sense to still harbor the user's post in the post table. Come on, it will definitely take up some space in our memory, and which is what we don't want to do, right? So once the user is deleted, which is the parent's record, also what? Pass the information down to what? Down to the child record, which is what? Which is the post table. And how did we achieve that? Just by adding this constraint over here. And let me explain this constraint. So this constraint is saying on delete cascade. What does this mean? On delete, what is it delete? Anytime we have a delete coming from the user's table, cascade. What is cascade? Cascade means, do you know do you even know the literal meaning of cascade? Oh, you know what we can do? Let's just go to Google and see the literal meaning of cascade, right? So let's come over to Google and say cascade meaning. So look at the meaning we're interested in over here. So it says what? pass something onto a succession of others, right? And what does that mean? On delete, cascade. What is the cascade? Pass on any information or any change happening in the parent table, which is the users table, down to succession. What is succession? The post table. Do you know the literal meaning of succession? Let's check the meaning of succession. So let's click this succession. And succession says what? A number of people or things of a similar kind following one after the other. It's meant to be clear at this instance. After knowing the meaning of succession, it says what? A number of people or things of similar kind following one after the other. And if we apply this definition to our database schema, it's saying what? Any change coming from the what? From the parent table should be passed effectively what? Down to what? Any child record. That's the meaning of what? On delete, cascade. Is it clear now? So it means any change you make to the parent table also make it also affect what? The child table. So right now, remember that when we wanted to change this ID of the users table, it refused, right? So let's change the ID of 2 to 10. So let's come over here and select the users. So this user has the ID of 2, right? And if we go to the post, we have an author ID of 2. But right now, let's change the ID of the user from 2 to 10 and see what will happen. Sorry, this is meant to be set ID to 10. So we are setting the ID to 10 where the ID is 2, which is this ID over here, right? So we are setting it to 10 where it is 2. So like right now, let's execute. Perfect. So let's select. So can you see the ID has been changed from 2 to 10? Then right now, let's go to the post table and see what will happen. And in the post table, look at the author's ID is now changed what? It's now changed from 2 to 10. This is the author's ID. Don't confuse it with this ID. This is the ID of the post. Look at the author's ID. That's what we're interested in. Now it has now changed from 2 to 10. Because of what? Because of this constraint over here that says on update cascade. So any updates coming from the child, from the parent record should also take effect immediately on what? On the child record. So that is what is this on update. Remember that when we try to update this, it said what you cannot update the parent record. So that's what we just did here on delete cascade, on update cascade. Okay, I know I said the last query was going to be the last query, but I forgot that we've not actually discussed on how to join multiple tables together, right? Because right now the tables are totally different, are separate from each other. So right now we have the post table and we have the users table. Fine and good. But now how can you tell the user that owns a particular post over here? Because in the users post we have 3 users, which is the user 3, user 4, and user 10. So their IDs, right? And in this post we have their author's ID to be 10 and 3. So you kind of know the user right now because it's a very pretty pretty small database, right? So if you have like millions of users and you have relationship between them, so how can you know a particular user that owns the post? You won't be able to know just by visualizing it like this, right? So we need to perform a join query. We need to join these 2 tables together and retrieve information from both tables, right? So how can we do that? We'll have to call the join method. We'll have to make use of the join query. So let me write a query, then I will explain. So we'll have to do select users. Okay, so what is this query doing? So what this query is actually doing is we are saying what? Select users.name. So what is this? This is users.name because now you are joining multiple tables. So you need to now reference the table that you want to select from. So we are saying what? Select from users table dot name. So we're making use of we are referencing this name, right? Then after that we are saying what again? So let me get this up over here so it will be easy for us. So after users.name we are saying select post.title. So this post.title, then we are saying post.content, this post.content, then we are saying from users. But now we know that this post.title and post.content is actually coming from these posts and not from the users, right? So we can't just do this. We can't just do this. It's saying what? Unknown column, post.title in field list. So what happened? I just like took off this. I commented it out, right? So let me just take it out. So if we cannot just do this alone, it's saying unknown column post.title in field.list, right? So it's saying that there is nothing like post.title in what? In users table. So that's why we are calling the join method. So the join query will now say, you know what? Select whichever one you have on your table, which is this users table from users. Then the remaining, select them from what? Select them from the posts what? From the post table. That's why we're now saying join on posts.authors ID is equal to users.id. So what are we saying over here? We're now saying wherever this ID that is coming from the users table matches the ID that is coming from the authors table, that is the post, that is the records that I want you to select, right? So right now if we hit enter authors.id, so what is the problem? Authors posts near on post.id, select join posts. So we forgot to add this. So join posts, right? Yeah. So we have to join this posts table over here. Then we now select it, right? So now if we hit enter. So do you understand what I did over here, right? So we are joining two tables. I forgot that. Sorry. So we are joining two tables. So we have to first of all join the table. So watch right now, we've joined two tables. We're using select star this from users, then we join this post table. Then after joining this post table, we are now saying on what condition should we join. So we are now saying just on the condition of where the ID coming from the user matches the ID that is in author's ID. And that is what we now did. And right now, we now have what? We now have our query. So now we are now having the post coming from the CS32 and the CS33. So right now we know the users that made a post. And if you're observant, you notice that what? It did not select what? It did not select the last user. Which is if we come over here and select this user. So if we hit enter, so you see it did not select this CS34. It's only what? It's only stopped at CS33 because that's the only user that has a post in the what? In the post table. It kind of makes sense, right? So this is how we execute join query. I know this might be a little too much, but just take things slowly, and maybe you might want to rewatch it again and again and again and practice. That's the only way you can get better. It's not by watching me or by staying here and looking at the screen and watch me from now to the next decade to come. You will never get better unless you get your hands dirty. So that's everything you need to know about the join query. And I think by now, everything concerned about SQL, SQL should be pretty clear to you. Because I really went into a lot of detail in this tutorial. And why did I choose to go through this route? Because you need a solid understanding of how to model database when you now start working on object relational mappers. It's even way better for me if I wanted to teach you object relational mappers, I just delve straight into teaching object relational mappers without going through this route. I mean, it will save me the stress. But why I love going through this route is so that I will teach you everything you need to know, the underlying details, the foundations of anything that we are trying to build the roof. I feel like you don't have to lay the foundations before building the roof. That's why I don't love starting from the roof. I love from the foundation. Because when the foundation is solid, the roof is you get what I'm saying? And that's it. Like I said before, I mean, I know this is not like a full comprehensive course on my SQL, right? But as I told you earlier in this video that this was not meant to be like a standalone course. It was meant to be a course or a part of a video, a series that I was recording, which is working with SQLAlchemy, right? And it's a very great course, I promise you. So you can actually check out for the video or for the course. I will put the link description either here or in the description below. So wherever you see the link, just click. So it was meant to be a part of a series, but I ended up creating a crash course. So the video was not planned. I didn't I had to sit down and plan about this video. No, I never did that. I was just recording. And at some point I figured out that I now have a very lengthy video, and I said, well, I just have to turn this into a standalone video, right? But just in case you didn't really get everything that you needed to learn about relational database like my SQL, you can now tell me, then I have to now create a full complete course or series on its own titled my SQL or Postgres database. Kind of makes sense, right? So this is like a freestyle walk. Makes sense, right? So that's everything you need to know. I needed to put that out. So in the next video, we now start what? We now start working with drivers and try to see how we write our SQL queries prior to the invention of object relational mappers. And it's going to make a lot of sense. Just stick around and enjoy the series. If you know your way about or around drivers, you can definitely skip. But if you don't know your way around drivers, watch the driver series, and after that, you can now watch the object relational mappers. You will have a solid understanding about what object relational mappers are, such as the SQLAlchemy that you make use of. That's basically everything you need to know. Then lastly, come on, there's a whole lot of work going in for this project and this series. So if you found the video helpful and you want to support the channel, just like, comment, subscribe. That's the only way you can support the channel. Share and support the channel the best way you can. And God bless you. Peace out.